October 23, 1942, El Alamein, Egypt. The desert night erupts in fire. 1,000 British artillery pieces unleash the greatest barrage since the First World War, their muzzle flashes turning the Egyptian darkness into a strobing hellscape of orange and white. General Bernard Montgomery has staked everything on this moment. The fate of North Africa, perhaps the entire war, hangs in the balance. And within minutes, everything begins to fall apart. Across the moonlit sand, British tank commanders are screaming into their radios, static, interference, nothing but electronic chaos flooding their headsets. The carefully coordinated armored assault dissolves into confusion as regiment loses contact with regiment, tank loses contact with tank. In the 9th Armored Brigade alone, 75% of their tanks will be destroyed in the coming hours, many because they simply cannot communicate with each other. Friendly fire incidents multiply. Flanking maneuvers arrive too late. Calls for artillery support vanish into the electromagnetic void. The statistics are devastating. British tank losses in North Africa have reached catastrophic levels. Over 3,000 armored vehicles destroyed, damaged, or abandoned in the Desert Campaign. Intelligence reports indicate that German panzer units are achieving kill ratios of 3-to-1, sometimes 4-to-1, against their British counterparts. The problem isn't courage. It isn't even equipment, though the German 88mm guns are formidable. The problem is that British tanks fight as individuals while German tanks fight as a single organism. And the difference comes down to one critical factor: radio communication. German panzer commanders can coordinate their movements in real time, executing complex flanking maneuvers while British tank crews struggle to hear anything through walls of static and interference. The standard British tank radio, the wireless set number 19, is theoretically capable of ranges up to 10 miles. In practice, in the electromagnetic soup of an armored battle, crews are lucky to reach tanks 500 yards away. What the generals in their command posts don't know, what the tank crews bleeding out in their burning Crusaders and Grants certainly don't know, is that the solution to their problem isn't being developed in some secret government laboratory or prestigious university research facility. It's being sketched on scrap paper by a 26-year-old technical officer who never finished his formal engineering degree. His name is James Ninnes Grant, and his stupid antenna modification is about to change armored warfare forever. To understand why Grant's solution was so revolutionary, you first have to understand why every expert in the British military establishment believed the problem was unsolvable. Radio communication in armored vehicles had been a nightmare since tanks first rolled onto battlefields in 1916. The combination of factors working against clear transmission seemed almost deliberately designed to frustrate engineers. First, there was the metal box problem. A tank is essentially a Faraday cage, a sealed metal container that blocks and distorts electromagnetic signals. Radio waves don't pass cleanly through steel armor. They bounce, reflect, and interfere with themselves in unpredictable ways. Second, there was the engine interference. Tank engines generate massive amounts of electrical noise, sparks from ignition systems, electromagnetic fields from generators, interference from every electrical component in the vehicle. This noise bleeds into radio systems, creating a constant background roar of static. Third, there was the antenna problem. Effective radio communication requires antennas of specific lengths, carefully tuned to their operating frequencies. But tanks can't carry tall, delicate antenna masts into battle. Enemy fire, tree branches, and even the tank's own movement would destroy them instantly. The standard solution, short, stubby antennas mounted to the hull, sacrificed range and clarity for durability. The Royal Signals establishment had thrown considerable resources at these problems. Teams of credentialed engineers from Cambridge and Oxford had produced detailed technical reports explaining exactly why significant improvement was impossible without fundamental redesigns of both the tanks and the radio equipment. Their conclusion, delivered with absolute certainty, was that armored units would simply have to accept poor communications as an inherent limitation of tank warfare. Better crew training, more powerful transmitters, improved receivers, none of these solutions could overcome the basic physics of the problem. The War Office accepted this expert consensus. After all, these were the finest scientific minds in Britain, backed by the full resources of the government's research establishment. If they said improvement was impossible, then improvement was impossible. Meanwhile, tank crews continued to die. The German approach to the same problem had been characteristically thorough. Their panzer divisions used a combination of standardized radio equipment, extensive crew training, and carefully developed tactical doctrine to achieve reasonable communication reliability. But even German tank radio systems suffered in the chaos of close combat. What neither the British experts nor the German engineers had considered was that perhaps they were thinking about the problem entirely wrong. Perhaps the solution wasn't better radios or more powerful transmitters. Perhaps the solution was a different kind of antenna. James Ninnes Grant was not supposed to be solving problems that had defeated Britain's best engineers. Born in 1916 in a small town in the Scottish Highlands, Grant had shown early aptitude for tinkering with electrical equipment. As a teenager, he had built his own crystal radio sets from scavenged components, learning through trial and error what university students learned from textbooks. He had enrolled in an engineering program, but left before completing his degree. The family needed income, and Grant needed to work. He found employment as a radio technician, first in civilian broadcasting, then with the military as war clouds gathered over Europe. By 1942, Grant held the rank of technical sergeant in the Royal Electrical and Mechanical Engineers assigned to the 8th Army's armored repair facilities in Egypt. His job was simple: fix broken radio equipment and keep the tanks talking to each other. It was unglamorous work. While other men earned medals and glory in combat, Grant spent his days elbow-deep in malfunctioning electronics, breathing solder fumes in stifling workshops, trying to make equipment work that seemed designed to fail. But Grant had one crucial advantage over the credentialed experts in London. He actually worked with tank radios every day. He heard the complaints from frustrated crews. He saw, firsthand, the consequences of communication failures. And he noticed something strange. Some tanks, Grant would later recall, had better radio performance than others, even with identical equipment. Same radios, same antennas, same crews, but different results. Nobody could explain why. The experts had attributed these variations to random factors: slight differences in component quality, variations in installation, even crew competence. Grant wasn't so sure. He began systematically documenting which tanks had better communications. He measured antenna installations with obsessive precision. He tested and retested, looking for patterns that others had dismissed as noise. And in November 1942, working late in his repair tent by the light of a kerosene lamp, Grant found something that made him sit bolt upright. The tanks with the best communications all had one thing in common. Their antennas, through accident or improvisation by crews, had been mounted in positions that created specific electrical relationships with the tank's hull. The metal body of the tank wasn't blocking the radio signals. It was acting as part of the antenna system itself. Grant worked through the night, filling page after page with calculations and diagrams. By morning, he had a theory and a plan to test it. The standard antenna mounting point on British tanks placed the antenna at the rear of the turret, connected directly to the radio set through a short cable. This position minimized interference with the tank's gun and kept the antenna as protected as possible. Grant's analysis suggested this was exactly wrong. By repositioning the antenna and adding a specific length of wire connecting it to the tank's hull in a particular configuration, Grant believed he could transform the entire tank into a resonant antenna system. The hull would no longer block signals, it would amplify them. There was just one problem. Any modification to military equipment required approval from the Technical Standards Board. Unauthorized changes to wireless installations were explicitly forbidden under Army regulations. Grant was proposing to modify dozens of tanks without any official authorization whatsoever. His first prototype was built in secret, using a salvaged Grant medium tank, the American-made vehicle that happened to share his name. Working after his official shifts ended, Grant fabricated a modified antenna mounting bracket and a peculiar arrangement of copper wire that looked, to untrained eyes, like nothing so much as a bizarre piece of modern art. It looked ridiculous, Grant admitted years later, like someone had decorated the tank with copper spaghetti. The first test, conducted in a remote area of the desert away from prying eyes, exceeded all expectations. Range improved by over 300%. Signal clarity, even with the engine running at full power, was dramatically better than anything Grant had experienced with standard installations. A tank that had struggled to communicate at 1 mile was now reaching clearly to 4. Grant knew he had found something important. He also knew exactly what would happen when he tried to report it. That is a violation of technical regulations. His immediate superior informed him when Grant requested permission to expand the trial. You cannot modify standardized equipment without board approval. The process takes months. And frankly, Sergeant, if the engineers in London say it cannot be done, it cannot be done. Grant was ordered to remove his modifications and restore the test tank to standard configuration. He did not comply. Instead of backing down, Grant did something that could have ended his military career. He began quietly modifying additional tanks, working with sympathetic crews who had heard about his improved communications. Within weeks, he had converted over a dozen vehicles, all without authorization, all in direct violation of his orders. Word spread through the ranks. Tank commanders who had experienced the difference began requesting the Grant modification by name. The unofficial network of improved tanks grew. It could not stay secret forever. In February 1943, Grant was summoned to a review board convened to address unauthorized modifications to standardized equipment. The panel included 3 senior signals officers and a representative from the Technical Standards Board in London, a full colonel with advanced degrees from Cambridge. Grant brought his data, charts showing range improvements, testimonials from tank commanders, technical diagrams explaining his theory of hull-integrated antenna systems. The room erupted. "This is preposterous," the colonel from London declared, barely glancing at Grant's carefully prepared materials. "You are not qualified to make these determinations. The physics have been thoroughly studied. What you are describing is simply impossible." "With respect, sir," Grant replied, "the tanks with my modification are achieving communications their crews describe as transformational. I have documented—" "You have documented a violation of regulations," another officer interrupted. "You admit to modifying military equipment without authorization. That alone is grounds for disciplinary action." The debate raged for over an hour. Grant's supporters, junior officers who had witnessed his system working, faced off against the credentialed establishment determined to maintain technical standards. Then Major General Raymond Briggs walked into the room. Briggs commanded the 1st Armored Division and had earned a reputation as a maverick who cared more about results than regulations. He had heard about the commotion and decided to investigate personally. After listening to both sides, Briggs asked a single question. Does it work? Sir, it absolutely cannot, the technical board colonel began. I asked Sergeant Grant, does it work? Grant met the general's eyes. Yes, sir. I believe it works better than anything we currently have. Briggs nodded slowly. Then I want it in every tank in my division by the end of the month. You can file your objections with Army headquarters, he added to the sputtering colonel. I'll file my after-action reports. We'll see which carries more weight. If you're finding this story of one man's determination against institutional resistance compelling, consider subscribing to Last Words. We document history's overlooked heroes, the innovators, the mavericks, the people who changed the world while the experts said it couldn't be done. Click subscribe, and you'll never miss a story like this one. The first large-scale test of the Grant modification occurred in March 1943 during training exercises in the Egyptian desert. The results stunned everyone who witnessed them. 40 tanks of the 1st Armored Division, all equipped with Grant's antenna system, executed coordinated maneuvers with a precision that observers compared to a flock of birds, each vehicle responding instantly to commands, maintaining formation through dust storms that would have rendered standard communications useless. Average operational range jumped from approximately 2 miles to 8 miles under combat conditions. Signal clarity improved so dramatically that tank commanders could now communicate effectively even while their vehicles were moving at full speed. Previously, almost impossible due to vibration-induced static. The technical board's representative submitted his report condemning the unauthorized modifications. General Briggs submitted his report praising them. The matter was escalated to the highest levels of Army command. In April 1943, the Grant modification was officially approved for deployment across all British armored units in the North African theater. The first major combat test came during the final push into Tunisia. On May 6, 1943, Sergeant William Peters of the 4th County of London Yeomanry led a squadron of Grant-modified Shermans against a German defensive position near Tunis. What happened next became legendary in British armored circles. Peters coordinated his 12 tanks like a single machine. While one group of 4 vehicles fixed the German attention with frontal fire, 2 groups of 4 each executed a perfect double envelopment, a maneuver that required split-second timing and constant communication. I could hear every commander as clearly as if they were in my turret, Peters recalled later. When Thompson's tank hit a mine, I knew instantly. When Davies spotted the flanking opportunity, everyone knew within seconds. We fought as one organism. The German defenders, a company of Panzer IIIs, were destroyed in 17 minutes. British losses, 1 tank disabled, no fatalities. The kill ratio that day was 12-0. German reports from the period reflect growing confusion about British tactical improvements. A captured after-action report from the 15th Panzer Division noted that British armored units have achieved unexplained advances in coordination. Their ability to execute complex maneuvers under fire has improved dramatically. Intelligence believes this may reflect new command structures or tactical training. They never suspected the truth was a stupid antenna modification invented by a sergeant without an engineering degree. Throughout May 1943, Grant-modified units consistently outperformed their previous capabilities. Tank losses in the 1st Armored Division dropped by 47% compared to the previous 6 months. The rate of friendly fire incidents fell by over 60%. Sergeant Frederick Collins, who fought in 3 major engagements with Grant-modified equipment, later provided testimony that became part of the official record. Before the modification, combat was chaos. You hoped your message got through. You guessed where your flankers were. You prayed you weren't driving into friendly fire. After Grant fixed our antennas, it was like someone turned on the lights. I could fight instead of just surviving. German pilot Lieutenant Hans Richter, who flew reconnaissance missions over Allied armored formations, noted in his diary. The British tanks move differently now. They respond to threats as a group, not individuals. We report positions, and by the time our panzers arrive, they have repositioned perfectly. Something has changed. This is the moment in Grant's story where one man's persistence began saving hundreds of lives. If you're enjoying this documentary, take a moment to like this video and share it with someone who appreciates stories of overlooked military genius. Every like and share helps us continue telling these forgotten histories. The technology spread quickly. By June 1943, Grant had been promoted to technical lieutenant and assigned to train teams in implementing his modification across the Mediterranean theater. By the end of the year, his system had been installed in over 2,000 British tanks. The Sicily invasion in July 1943 saw Grant-modified units achieve coordination that allowed outnumbered British forces to outmaneuver German armored reserves repeatedly. The Italian campaign that followed became a proving ground for tactics that would have been impossible without reliable tank-to-tank communication. James Ninnes Grant was recommended for the Military Cross in recognition of his contribution. He declined, suggesting instead that the commendation be distributed among the tank crews who had first agreed to test his unauthorized modifications, risking their own careers to prove his theory. "I just fixed an antenna," Grant reportedly said. "They're the ones who proved it worked under fire." The Grant modification, officially designated Antenna Modification Pattern No. 7 in Army records, was incorporated into standard British tank production by late 1943. American armored forces, impressed by the results, developed their own version based on Grant's principles. By the end of World War II, over 15,000 Allied tanks incorporated some version of Grant's hull-integrated antenna system. After the war, Grant returned to civilian life, taking a job as a radio technician with the BBC. He never sought publicity for his wartime contribution, never wrote memoirs, never gave interviews to journalists seeking to document his innovation. He could have been famous, a colleague recalled. Companies wanted to hire him. Universities wanted him to lecture. The ministry wanted him for consulting. He just wanted to fix radios. Grant lived quietly until his death in 1987, largely forgotten by the public, but remembered by the tank crews whose lives his invention helped save. The principles he discovered, that a vehicle's hull could be incorporated into an antenna system to dramatically improve radio performance, proved foundational to military communications development. Modern armored vehicles still use integrated antenna systems derived ultimately from Grant's stupid modification sketched on scrap paper in an Egyptian repair tent. Sergeant Frederick Collins, the veteran who testified about Grant's invention, tracked down the inventor in 1978 and visited him at his home in Scotland. "I had to tell him," Collins explained later. "I had to tell him that he saved my life, probably a dozen times over. Because of you, I told him, we came home. Because of you, we fought like soldiers instead of dying like targets." Grant's response was characteristic. He made tea, showed Collins his radio equipment collection, and refused to discuss his wartime work beyond acknowledging that he had been lucky enough to notice something others had missed. The technical. Standards Board colonel, who had so vehemently opposed Grant's modification, never publicly acknowledged his error. But his post-war career included significant support for research into unconventional antenna systems, perhaps a silent admission that the sergeant without a degree had seen something the credentialed experts had missed. History remembers the generals and the battles, the political leaders and the grand strategies. It rarely remembers the technical sergeants who fixed the unfixable and changed warfare in the process. But the soldiers remember. In cemeteries across Europe and North Africa lie men who came home from war because their tanks could finally talk to each other. Their grandchildren exist because a young Scottish tinkerer refused to accept that the experts must be right. James Ninnes Grant never sought recognition. He never claimed to have won battles or changed history. He just fixed an antenna. And in doing so, he made 40 tanks fight like one machine.